Okay, ladies and gentlemen, this is Mr. Green again, and this is another in my series of discussions about Algebra 2. Now, what we did last time was we talked about multiplying polynomials. You might guess that the next topic is going to be dividing polynomials. Well, there's something that comes before that. First thing that comes before that is factoring. To be able to divide, we need to be able to factor the polynomial into its subparts, okay? So factoring a polynomial expression by factoring out the greatest common monomial factor is step number one. Okay? Use factoring patterns to factor polynomial expressions, difference of squares, and perfect square trinomials. That's one of the second things that we're going to be looking for. Okay? And then looking for some trinomial expressions. We'll get to that a little bit later on. But those are the things that we are looking at right at the moment. Okay? So let's talk about some factoring techniques. Technique number one, factoring by greatest common factor. We're looking for the greatest common factor. This is something you've done for quite a few years. I know you were doing it in early elementary school. So let's look at these two numbers here, 42 and 60. Well, they're both even, so you might say the greatest common factor is a 2. Well, it's not. You could say, well, they're both divisible by a 3 because 42 goes in there 14 times and 60 goes in there 20 times. You're right. They are both divisible by 3. 3 is not the greatest common factor. Well, they're not divisible by 4 or 5. You know what? They're divisible by 6 because 6 times 7 is 42 and 6 times 10 is 60. Yes, it is. Is that the greatest common factor? Well, 7 goes in here, but not here. 8 doesn't go in there. 9 doesn't go in there. 10 doesn't go in there. 11 doesn't go in there. 12 doesn't go in there. 13 doesn't go in there. 14 doesn't go in there. 15 doesn't go in there. I think you can stop. One of the ways I like to do greatest common factor is to actually factor the numbers. So I draw the factor trees. 42 breaks down into 2 times 21, breaks down into 3 times 7. And 60 breaks down into 2 times 30, which breaks down into 3 times 10, which breaks down into 2 times 5. Now I look for common factors that are at the end of things. I see a 2 here and a 2 here. I see a 3 here and a 3 here. But I don't have any other commons. This is a 7, that's a 2, and a 5. So if I multiply the 2 times the 3, I get the 6, and my GCF is 6. That's the way I like to get the greatest common factor when I'm looking at numbers, if I don't see it right away. Now, I'm not going to do too much of that in here because, quite honestly, it's one of those things you should have been doing for a long time, so I'll be moving forward past that. If I'm looking at 25a squared and 15a, I can see that there's a 5 in this one and a 5 in that one. The 5 is going to come out. And I can see that this has got an a squared, that's got an a, so they both have an a in them, so the a is going to come out. And when I factor it out, I'm going to be left with 5a here, and I'm going to be left with a 3 there. What if these were combined together with a plus sign? Just like this, 25a squared plus 15a. I would do the exact same thing. I would pull out the 5a and leave me with 5a plus 3. And if you don't believe that's the right answer, you could always use the distributive property and make certain you got the right thing. But that is the technique that I use to find that greatest common factor. Okay, looking at this one, what I see in here is they're all negatives. That means I'm going to have a negative number I'm going to pull out of there. I see that they're all divisible by 3. But this one's even and these two aren't, so it's probably just going to be a 3 that I'm pulling out of each one of them. So what I'm going to look at is pulling out a 3 out of negative 6. That's going to leave me with a 2. If I pull a 3 out of a 15, that's going to leave me with a plus 5. And if I pull a 3 out of a 9, that's going to leave me with a plus 3. Okay? Well, I haven't finished yet because I see a c in each one of these. And c to the fourth minus c gives me c cubed. And c squared minus a c, or divided by a c, gives me a c. And a 9c divided by a c gives me a c. I'm sorry, gives me a 1. So that would be my answer right there. Negative 3c times 2c cubed times 5c plus 3. Once again, distributive property. 3 times 2 gives me negative 6c to the fourth. Negative 3 times 5 gives me negative 15. C times c gives me c squared. Negative 3 times 3 gives me negative 9. C times 1 gives me c. Cool. Okay? Let's try another one here. 12, 24, and 16. My common factor is 4. Okay? That means I'm going to be pulling out a 4 out of a 12. That's a 3. A 4 out of a 24. That's a 6 plus 6. And a 4 out of a 16. That's a 4. Negative 4. I can look here and I see an x cubed, an x squared, and an x squared. I'm going to pull out an x squared out of every term. That's going to leave me an x here, and it's going to leave me a 1 in each of those, which is multiplied by 1, doesn't do anything. I see a y squared, and a y cubed. I'm going to pull out a y squared. That's going to leave me a 1 here. It's going to leave me a 1 here, but it's going to leave me a y down here. That would be my factor. Okay. This is beginning to take some shape. I'm beginning to see how it's working here. Well, I'm going to throw another technique at you. I'm going to start factoring by grouping for polynomials. So if I see 4 more terms, I'm going to group them together. But I'm going to look for pattern behavior too. That was one of the things we talked about on the first slide there, that there's some pattern behavior. Okay? So let's look at some of these. The factor by grouping. All you do if there's 4 more terms is you group the first 2 together and you group the last 2 together. That's nothing more than drawing parentheses around them, and factor out the greatest common factor of each one of the groups. You know what? A lot of times it works out that you're left with the same factor. For example, b cubed minus 3b squared plus 4b minus 12. I'm going to draw parentheses around the first 2, draw parentheses around the second 2, leaving this sign, whatever this sign is. Okay? If it's plus, it's a plus. And I want you to notice, in this one, there's a b squared in both of them, so I pull b squared out, and I'm left with b minus 3. In this one, there's a 4 in both of them. I pull the 4 out, and I get a b minus 3 and b minus 3. If I pull the b minus 3 out, I'm left with a b squared plus 4. Where'd the b squared come from? Right there. Where'd the 4 come from? Right there. All I'm doing is pulling out the greatest common factor of this one and this one. That works, Mr. Green. That's pretty cute. Let's try it again. 2x cubed minus 16x minus 8x plus 64. They're all even. I'm going to pull a 2 out. X cubed minus 8x squared plus or minus 4x plus 32. Group the first 2 together, group the last 2 together. You notice how I took this minus sign? It's a minus 4x. I left that minus 4x right here with the 4 and put a plus sign here. Okay? So on this side, x cubed minus 8x squared. I see an x squared in both of those, so I'll pull out an x squared and I get an x minus 8. Over here, if I pull out a minus 4, it's going to give me the minus 4 times x and a minus 4 times negative 8. Why did I pull a minus 4 out? Because I wanted to get an x minus 8. See how it worked out real easily there? And I get x minus 8 as a factor and x squared minus 4. Wait a second. Pattern behavior. This is called a difference of squares. See how it says x squared minus 4? That is a patterned behavior. Okay? I can always take x squared minus 4 and factor it into x minus 2, x plus 2. All I'm doing is taking the first term, x, and putting it down, and the minus 4 becomes a minus 2 plus 2, because that's the square root of the 4. Anytime I've got a perfect square sitting here in the second term, pointer helps if I use it. Anytime I've got a perfect square sitting here in this second term, that's when I see a difference of squares. And that's one of the things you've got to begin to look for as a patterned behavior. That's one you'll see frequently. So let's look and try to do some of these on our own without having them already drawn for us. So I've got 4x squared parentheses minus 3x parentheses plus x parentheses minus 12xy parentheses. Taking this first one, well, there's no common terms between 4 and 3. X squared minus y, no common terms there. And then I've got an x minus 12xy. There's an x there. But you know what? I'm not getting enough common terms here that it's going to make any difference. So let's do a little trick. The trick I'm going to do is I'm going to remove those parentheses. Dink. Dink. Gone. And I'm going to say, let's use the commutative property. Commutative property says I can move things around. 4x squared plus x minus 3y minus 12xy. Why'd I do that? I swapped these two terms right here. Right? Why'd I do that? Because now when I group these two together, I can see that I'll have an x that I can pull out of them. And I'll have a 4x plus 1. Okay? Now when I take this minus sign, turn it into a plus, that becomes a minus 3y. Group these two together, and I pull out a plus 3y out of this. What am I going to get? I'm going to get a 1 minus 4x. Wait a second, this one and this one aren't the same. But you know what? If I made this a minus 3, then this becomes a minus 1, and that becomes a plus 4. And then I can rearrange that, and I get 4x plus 1 plus negative 3y times 4x minus 1. Where did I get the minus sign? Oh, it was a minus 3y, so it should have been a plus there. Sorry. Dropped a negative sign. That'll kill you every time. Okay? So if I pulled out the minus 3y, that would give me a 1 here, and it would give me a plus 4x there. That gives me 4x plus 1 there, parenthesis. Now I've got 4x plus 1 in both terms, so what do I have? I've got x minus 3y as one factor, and 4x plus 1 as the other factor. Please check me. Make certain I've done this correctly. Okay? This one, I'm going to group these together with the x squareds together and the 4y plus 12 together. So when I do that, I'm going to get this like this, and this is going to be a plus minus 4y grouped like this. So when I take out the x squared out of this term, I'm going to get y minus 3 plus parenthesis or 4x or 4y. Nope, not 4y. Jeez, sorry, messed up there. Back up, erase. Think. Thank you. You got to make certain you do it right. So I'm going to pull out a minus 4 out of both of those two terms. I'll get minus 4 times y minus 3. Minus 3 times minus 4 gives me the positive 12. Okay, so I've got y minus 3 in both terms. Y minus 3 becomes this term, and my other term becomes x squared minus 4. Ding, 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 ding. Perfect square, perfect square. Difference of squares. This becomes y minus 3, x minus 2, x plus 2. See what I said it shows up frequently? That's what you need to be looking for. Cool. Now this next one is an idea that has come to me from another teacher. She likes using factoring by mama table. Mama table. wow, what in the world's a mama table? Well, I'm going to show you real quickly. You saw me last time when I was multiplying polynomials together, binomials and things like that. I used my little my little box like this, right? And I showed you how I could multiply the y times the y, I got y squared. 2 times y, I got 2y here. And y times 4 gave me 4y. And y 2 times 4 gave me 8. And when I combined the like terms, I got 6y. Right? Well, using this concept, we can create a little table. And one of the tables we're going to look at here is I want to factor this 6y plus 8. I'm going to create a factor tree. I want to factor 8. I want to write down everything that is a factor of 8. That'd be 1 times 8, 2 times 4, a -1 times -8, and a -2 times -4. Those are the 4 terms that I would write there. But they have to add. Remember when we were doing this? These two added together to give me that 6. So we've got to add to get that middle term here. So 1 plus 8 gives me a 9. 2 plus 4 gives me a 6. -1 plus -8 gives me a -9. -2 plus -4 gives me a -6. These don't work in the equation. This is the only one that works. This would be the term that I would use to break it apart. And what I mean by break it apart, it's going to be, and they're going through this individually here. You can see they get the 2 plus 4, positive 6. That's going to be the right one that we're going to want to use, right? We're now going to place those numbers, and we're going to break this equation apart. What do you mean? Well, I'm going to take that 2 plus 4 and replace the 6 with it. And it's going to be y squared plus 2y plus 4y plus 8. Now I've got 4 terms. If I've got 4 terms, I can go ahead and group them together. Factor out the y here, factor out the 4 from here, y from here and the 4 from here, y plus 4, y plus 4, and y plus 2. I just factored it. Okay? Maybe if you see me do this on my own. What if we were trying to factor this? I'm going to find all the factors of -63. -63 and 1, 1 and -1 and 63, -21 and 3, 3 and 21, -9 and 7, -7 and 9. I'm going to go through and add them. That's going to give me a -62. Nope, don't want that one. I'm going to get 62 on that one. Nope, I'm looking for a -2. -21 and 3, that's a -18. That one won't work. Remember, I'm looking for a -2 here, aren't I? This is what this other teacher, Miss Prissy, calls her mama table. I'm looking for that -2. Where did the mama come from? Ma. And you do it over again. Mama, mama, mama. Okay? -3 and 21, 18. Nope, not it. -9 and 7. That one equals -2. That's going to be my numbers. -9 and 7. So I'm now going to break that equation down into x squared minus 9x plus 7x minus 63. And I'm going to see by grouping these two together, I can factor out an x. Grouping these two together, I'll be able to factor out a plus 7. Okay? Plus sign there, missing. So factoring out that plus 7, and I still got this x plus 9 as the common term. There's one term, there's the other term. Wee doggy, that was easy. It is an interesting way of doing it. Just some hints on the mama table. If your last term is positive, my factors are going to have the same sign. They're either both going to be negative or both going to be positive. It depends upon what the sign of the middle term is. If the middle term is a negative number, then they're both going to be negative, and it's going to add to that negative term. If the last term is negative, then the two factors are going to be different signs, and you can look at the middle term and you can say, well, which one needs to be the bigger one? If it's a positive term in the middle, it's going to be the positive number. If it's a negative term in the middle, then it's going to be the negative one. That simple. So here we got 5x squared minus 17 plus 14. I'm going to factor 70. Where did the 70 come from? Well, you know what? See how this 5 times the 14? That's where the 70 comes from. I multiply these two terms together, okay? When I multiply them together, that's what I'm trying to find the factor of. So negative 1 and 70, nope, that adds up to negative 71. Negative 2 and 35, that's negative 35. And negative 7 and 10, well, that's negative 17. That's going to be what I break my terms down into. When I group them together in that original equation, I can then factor out the x and the minus 2. I get x minus 2 times 5x minus 7, and it worked quite easily. Okay? I'm going to work a couple more with you here so that you see what's going on. 2 times 12 is 24, right? So I'm going to be multiplying to get 24 and adding to, oh, wait a second. I said 2 times 12 is 24, but look, they all have a 2 in them. So I'm going to factor that 2 out to begin with. And now I've got a 1 times 6 is 6. That's what I'm going to be multiplying by. And I got a negative 7 here. That's what I'm going to try to get them to add to. Since this is a negative number, they're going to be opposite in sign. I'm sorry. Since this is a positive number, they're going to be the same in sign. Negative 1 times negative 6 and negative 2 times negative 3. Same sign. How did I know they were going to be negative? Because this is a negative number here. This is a negative number. They have to add to a negative number. So negative 1 times 6 gives me that negative 7. 2 times that gives me a negative 5. That's not going to be the right term. Break it down into its parts. X squared minus x. That's where the negative 1 came from. And x negative 6x plus 6. Then I can group these together. And I'm going to get an x out of this term and an x minus 1. And I'm going to get a 6 out of this term, and I'll be left with an x. See the minus sign there? I need to come inside. Sorry. Negative 6 here, and I'll be left with an x minus 1. Those will come factor out, and I'll be left with x minus 1 and x minus 6. Don't forget the 2 that we factored out to begin with. Okay? Always look for that greatest common factor to begin with. Okay, here. This is going to be my last one I'm going to do. I've got a 1 here and a 33. So I'm going to write my mama table over here. They have to multiply to give me 33. It's a positive number. And they have to add to give me a 14, a positive number. That means I'm only going to be looking for positive numbers here. So 1 times 33, that's a 34. No, not going to be that one. 3 times 11, that's a 14. You know what? That one works. So what I'm going to do, I'm going to break it down. X squared plus 3x plus 11x plus 33. I'm going to now group my first two together, group my second two together, and I'm going to factor out of them. I get an x and an x plus 3. Over on this other one, I get an 11 and an x plus 3. I've got an x plus 3 in both places. X plus 3 times what's left, x plus 11. There are my factors. Ta-da. Okay? Hopefully this has helped you see how to do some factoring. Why is this important? Because factoring this way will help us when we get to dividing polynomials. Because a lot of times in dividing polynomials, what we're looking for are binomials that will cancel out. So we're looking for those type of things that will cancel out, that will help us in the future. Okay? So don't forget, lots of courses. Make certain you tell me that you're in Algebra 2. If you send me questions, come by Toga if you have any questions. I want to try to help you understand this mama table.